This conference will now be recorded.
Hello, good afternoon and welcome to the day 2 of our Monitoring Soil Moisture Using Earth Observation workshop, brought to you by the Caroline Herschel Framework Partnership Agreement for Copernicus User Uptake project. It's funded by the EU and coordinated by DLR, German Aerospace. My name's Lynn Healy. I'm a Technical Project Manager at JNCC, the Joint Nature Conservation Committee. I sit in the digital and data team, which delivers a range of functions, including data engineering, infrastructure, and application development. Working with the JNCC Earth observation specialists, we led the way in delivering the automated processing of Sentinel-1 and 2 data to the analysis-ready data standard used in the UK public sector. I provide technical and business analysis advice on a range of projects, and I'm currently leading the Copernicus User Uptake project at JNCC as part of the Caroline Herschel Partnership Framework. This project is delivering a program of activities, including this workshop. I'll be your chair for today's session. For those of you who don't know us already, the Joint Nature Conservation Committee is the public body that advises the UK government and devolved administrations on UK-wide and international nature conservation. We are an impartial scientific authority, and we provide advice on practical, policy-relevant, evidence-based solutions to support decision-making. The aim of this workshop is to introduce delegates to the potential role of Earth observation data, products, services, for monitoring soil moisture, especially from the Copernicus programme, but also to have a wider discussion about soil moisture, data networks, and application for use of these data. Hopefully you'll have already found the virtual spaces that we've set up to allow you to interact with each other, as you might expect at a workshop. We hope that you'll not only walk away from our event with more knowledge about these data, but will have had a chance to share, explore, and refine ideas with each other as well. Before we go any further, I'm not moving my slides on, sorry. See if we can do that. Oh, there we go. Before we go any further, I've got a few housekeeping rules to remind you of. You will have received a detailed agenda and information sheets explaining the rules beforehand. Please note that we'll be recording today's session and making these publicly available via JNCC's YouTube channel. If you wish to ask the speakers questions, please do so through the meet.ps/JNCC soil link. We'll put the link in the chat because the one in the information we sent you originally was slightly incorrect. All questions are asked anonymously. If you've not seen it yet, the question space looks like this. Hopefully it's fairly intuitive, but if you need help navigating the space and the one I'm going to show you in a moment, then we've sent you some fairly detailed notes on the Friday before the workshop. So this is the collaboration space, and if you've not already introduced yourself to others and would like to do so, you can do so here in the Introduce Yourself section. And this is also where you'll find the collaboration session space, which will open later today. You won't see it on the menu yet because we've not opened it yet. So this space will be open and available until the 29th of July so that you can collaborate with each other after the event. Please note that all the posts that you make and the comments in the networking and the collaboration spaces carry your name as you entered it at the login time. If you need a hand to find your way around, you'll have already got that information. Please be polite, positive and constructive in your questions, comments and feedback, usual rules. Other materials such as PDFs of the slides, questions and collaboration transcripts will be available through SharePoint for anyone with a link, which will be publicly advertised, and we'll also email it to you all directly. Please feel free to tweet about the workshop using hashtag JNCC_EO for soil and tag @JNCC_UK. If you need to leave early, please fill in our feedback form to help us improve future sessions. All the feedback's anonymous, so please be honest with us. For those of you who attended day 1 of the workshop yesterday, I hope you found it as interesting and enjoyable as I did. For those that have joined us for the first time today, yesterday's session looked like this. It was led by Dr. Gwar Jones, Senior EO Earth Observation Specialist at JNCC, and focused on the introduction to the Soil Water Index and surface soil moisture products, how these were validated, and how to access and use them. The speaker was Dr. Bernhard Bauer-Marschallinger from TU Wien, the Vienna University of Technology, and he's the lead author of the Copernicus, SSM, and SWI documentation. The recordings from day one will be available shortly through the JNCC YouTube channel and will be available until the 29th of July. Today, we've got a packed agenda focusing on 3 main topic areas: validation, use cases, and potential collaboration. Our speakers today are Matt Fry from the UK CEH, Dr. Riccardo Dainelli from the Institute of Bioeconomy, National Research Council in Italy, Fernando Roque from Quantic Statistics in Guatemala, and Anisora Irimescu of the National Meteorological Administration, Romania. So now to start the first session. Again, just a quick reminder, this is the question facility. If you've got any questions, please use this and not the meeting chat. The meeting chat's just for technical issues and messages to the organizer, etc. So I'll stop sharing my screen so that I can introduce the first session. Today's first session is the second part of the validation and ground truthing. Yesterday, we heard about the process used to validate the surface soil moisture and soil water index products. In today's session, Matt Fry from UK CEH will introduce us to the Copernicus In Situ and Cosmos UK projects. I'm now pleased to introduce Matt Fry. Over to you.
Hello everyone, can you hear me? Can you see the screen?
Yep, we can hear you.
I'm just about to start. So I'll have the camera on now just to introduce myself and say hello, and I'm going to turn it off for precaution against Zoom bombing by my children. So can you see the presentation mode? No.
We can see the slides down the side.
Yep, I'm just going to see if that works. How's that? Can you see the?
That's great. Yep. Thank you.
So yeah, thanks very much for asking me to talk today. And I was very impressed yesterday with the talks. It was a really interesting afternoon. Great to hear from Bernhard and all the real level of detail that you can get into in a workshop like this. So it was really, really enjoyable from my point of view. I can't promise the same level of expertise today, but I'll do my best. So, and we've got time for some questions and answers after this first set of slides. So I'm going to talk for a while on a couple of topics. So yeah, just to introduce myself, my name is Matt Fry. I work at the UK Centre for Ecology and Hydrology. So we're a UK level research organisation working across the whole area of terrestrial and freshwater environment. A lot of history in hydrological monitoring and hydrological applications, including early uses of soil moisture measurements and use of soil moisture modelling. And recently we've been working focused on this Cosmos soil moisture monitoring network. So I'll be talking about that. But first of all, I'm going to mention another project that I'm working on as part of the Copernicus program. I thought it was relevant to this, called Copernicus In Situ. So let me see if I can progress my slides. Is that working? That seems to be there. So Copernicus In Situ is a kind of cross Copernicus project. So as was mentioned yesterday, lots of Copernicus is delivered through these particular services for, say, for atmospheric monitoring or for emergency management service or marine service. But Copernicus In Situ is it sits outside those services and looks to address issues with access to in situ data. So it can't actually kind of fund new monitoring and those sorts of things, but it tries to map the landscape of in situ data availability, looking where there are problems with accessing either data that's already measured or data that's not being produced to the level that's needed for satellite product development, identifying bottlenecks, and it tries to support the provision of data across the services. So where there's particular work being done within an individual service, try to make sure it's used across services, working with partnerships and things like licensing and those sorts of things. So as part of this, we've had a sub-project on hydrology. It's only been running for the last sort of year and a half, but we're just about to start a new period on that. And I've been leading this part of this project, focused on hydrology data in particular, in situ data. And when I talk about hydrology, that covers river flows, river lake levels, river and lake water quality, and soil moisture. So it's looking at where in situ data is used by the Copernicus services in those areas, whether there are issues with access to that data, whether there's issues to actual availability of that data in general, with the aim of kind of highlighting the need where the needs are, improving access where we can do coordination work that will help to improve that, and identifying avenues in future to improve the availability of in situ data. So like I mentioned, part of that is on soil moisture. We've had a report written recently. Was that not? I thought there was a link there. There's a report on the Copernicus in situ website on hydrology, access to in situ hydrology data. And in terms of soil moisture, the findings are fairly limited in that there's a fundamental limitation in the soil moisture in situ data that is available for the development and validation of these products. And I think Bernard touched on this yesterday, that a lot of the validation is done through comparisons to modeled data, with some in situ data across Europe and America, but in very limited amounts across the rest of the world. So it's basically a fundamental lack of measurements that are limiting that. But the data that is available is well used by the Copernicus services in all the soil moisture products. This is something that was mentioned yesterday, the International Soil Moisture Network, which is a kind of global, a collation of that data globally, is all very available and very easy to access and is well used in those development of those products. So like I said, there's no issues with data sharing, and the idea of the, in the area of soil moisture, there's a limited amount that we're focused on, maybe highlighting the sustainability of those data access, highlighting the need for more measurements, and in particularly highlighting the kind of need for field scale measurements, because there always have been issues with the point measurements, both in terms of the reliability and also in terms of the kind of representation of how well they represent what's potentially quite a kind of heterogeneous soil body on a larger scale. If you're measuring in one particular place, you're not necessarily accessing true soil moisture information. So that's just a very quick summary of some of the work we've been doing in the Copernicus in situ project. And on that last point, on the need for more field scale measurements, something I'm going to talk about next. So moving on to Cosmos UK, which is a project, a monitoring project that UKCEH has been undertaking since 2013, with the aim of establishing across the UK a real-time field-scale soil moisture monitoring network using what was quite a new and innovative monitoring solution called the Cosmic Ray Soil Moisture Sensor. And I'll explain a bit about how that works as we go on. So like I said, it was established in 2013. We just started off with 3 sites, and we've been putting a lot of work into establishing new monitoring sites for soil moisture across the country since that point. And this work's been funded through NERC, the UK Natural Environment Research Council, and some of our national capability funding that we get from NERC for this type of work. So it's very much a research network. Sorry. Very much a research network. So we're doing a lot of additional measurements that aren't just based for kind of direct monitoring of soil moisture. We're trying to understand this the monitoring technique and use it to understand soil moisture processes, as well as just kind of understanding the soil moisture at a particular time. And that point there about field scale monitoring, field scale soil moisture is a key point in terms of the aim of the network. Let me move on. So there are a huge range of applications for Cosmos UK that we're involved in a number of networks and groups of people working across a whole area of water services and different areas. So we're making sure that we're kind of linking up with those organizations with an interest in all the different types of things that soil moisture is going to influence. And there's just some of the kind of areas of interest. Process understanding in terms of hydrological processes is obviously key for us as a research institute. Hydrological modeling, groundwater recharge, whether it's useful for prediction of crop yield, irrigation scheduling. Another key area is input to land atmosphere models, where understanding of soil moisture can really make significant differences in climate modeling and weather forecasting. Understanding how soil moisture affects greenhouse gas emissions, for example, from agricultural fields. Climate studies, drought monitoring, flood forecasting, weather prediction, like I said, and outlooks in particular of the hydrological situation. So we're trying to set up a network that is useful across all of these areas. And obviously Earth observation data will obviously feed into those same areas. So that the link between the monitoring data and the Earth observation and where we can get the benefits of both is a key point. So what is the COSMOS network? So as I said before, it's called a cosmic ray soil moisture sensor. You can see on the right of this diagram here, this little white tube just looks like it's part of the post, but that's actually the COSMOS sensor itself. So it's a passive sensor. It sits above the ground. It doesn't have to be buried. It doesn't have to disturb the soil, and it doesn't have to be. It's not affected by the quality of the way that it sits within the soil, how well developed it is. It's a kind of automatic sensor, so it just runs with logging data, and we get the data by telemetry automatically. There's no, sorry, somebody's saying they can't see the presentation. You could let me know whether that's just one person or everybody.
I can see it.
Right, I'll assume that everybody else can then, and I'll carry on.
Yeah.
So it's a field scale, like I said. It looks around 200-meter diameter in the UK conditions. It varies depending on the conditions. I'll talk about that again in a moment. Similarly, it looks up to 80 centimeters into the soil, but it could be different depending on the particular conditions at a time or particular site. So it provides us with field landscape scale soil moisture data in basically near real time that we can use for those various applications. I should say at the beginning that I'm presenting this work on behalf of a big team of people who are doing all sorts of aspects of managing this network, identifying sites, installing equipment, running the telemetry, running the data systems, analyzing the data, and the whole cycle of work around it. So some of the questions you might have at the end might be on specific aspects of those, and I can. If I can't answer them myself, I can pass them on to the key people. But it is it's a joint effort of a large group of people. So how does the cosmic ray neutron sensor work? So cosmic rays come from space, from outside the solar system, and they're streaming in constantly into the Earth's atmosphere. Not something that you notice on a day-to-day basis. And they produce a shower of high energy neutrons, which may reach the Earth's surface. So that first graph we see at the top there, showing that you get high energy neutrons coming into the upper atmosphere. Has that presentation just stopped again? Okay. And there's sorry, my presentation keeps jumping around. Can people see the presentation normally as a full slide show, or is it showing just the slides at the moment?
It's not in slideshow mode for me.
It's not, no, sorry. It keeps
every time jumping out.
I move my mouse, it keeps jumping out. We'll see how we get on. So there's a spectrum of the energy of those neutrons as they come into the atmosphere. So you get a particular peaks at high energy or low energy, particular particular peaks at high energy as the electrons come into the atmosphere. They come down through the atmosphere, losing energy on the way, and low energy neutrons are further slowed and partly absorbed by hydrogen atoms in the soil. Some lower energy fast neutrons are scattered back out of the soil, and those are the ones that the cosmic ray neutron sensor measures. And basically the amount of water, the amount of hydrogen atoms in the soil, which is obviously directly proportional to the amount of water in the soil, is directly related to the number of neutrons that are counted by the cosmic ray, this white tube, as I mentioned, the cosmic ray sensor. So you get a wetter soil and you get fewer neutrons. In drier soil you get more neutrons, or higher counts. But it's also worth noting that when at a wetter soil you're getting fewer measurements, they're much more impacted by water near the surface. So basically the effective depth of the measurement that you're making when it's wetter is lower, so much nearer the surface, than when the conditions are drier, where it's measuring over a larger effective depth. So it's measuring the effect of water molecules over a bigger depth, a bigger volume when it's drier. So it's quite key to understanding the measurement in that the effective depth over which you're measuring changes depending on the conditions. But particularly as it gets drier, we know we are measuring deeper down into the soil, so we're getting a good understanding of the soil moisture as conditions are drier, which again is worth contrasting with the Earth observation products that we talked about yesterday, where they're quite heavily influenced by moisture at the soil. And understanding of water at depth was is kind of modelled on that and those different T layers that Bernard mentioned yesterday. So when you're thinking about using the data or using it with Earth observation data, it's really key to get and to bear those things in mind. So the other aspect I mentioned was as the impact of the water in the soil changes further away from the sensor as well. So you're getting a much stronger signal from water at the point of the sensor and less of a signal from water further away from the sensor. So while we've got this big, approximately 200-meter footprint, the area closer to the sensor has a larger influence on the measurements we're making. Nonetheless, it is a field scale measurement that we're taking. Don't worry about the details of the slide, but this is just to show that this is how we move between these neutrons that we've counted to an actual measure of volumetric water content. So there's a modeled curve based on modeling of neutrons and the processes. And if we can make a calibration measurement in our particular site, we can use that we know that the curve will take a particular shape from that calibration measurement. So we should only need to take a single calibration measurement to identify that relationship across the range of neutron counts that we're going to get to convert that into soil moisture. So that's a kind of my level of explanation of the detail of the method. There's a whole area of literature around this that you're more than welcome to read, or you can ask questions about, but I might not be able to answer very many in terms of the details of neutron collision modeling today. So this is the point I was making about the soil moisture depth and the radius, that we're looking at footprint, and we're looking at in different conditions, wet and dry, having the fractions of neutrons that come from a different depth changing with the depth and with the conditions, but in terms of the change of where the measurements are made within that footprint, so the diameter of the footprint, they do vary slightly between wet and dry conditions, but much less so than the impact on the depth. So the depth is very sensitive to wetness. And we actually, one of the data sets we provide with the Cosmos data is this effective depth that we're measuring. So the depth of a key within which a fixed kind of proportion of this soil moisture counts are, these neutron counts are coming from. And I'll kind of explain that a bit later. So like I said, there's a number of, it's quite a complicated method in terms of converting from counts of neutrons from space to get to a soil moisture measurement. And it involves a calibration, as I said, but it also involves some other corrections. So we get neutrons that come through the atmosphere. Obviously, they're affected by a number of water in the atmosphere as well as in the soil. So we have to measure atmospheric pressure and humidity and air temperature and use that to account for the counts that are coming in. So we get a kind of corrected counts. We also account for background neutron intensity because that vary, the neutrons that come in from space vary over time. And we take data from a kind of a station that's looking at this for the purposes of atmospheric physics or cosmological physics. So in Jungfraujoch in Switzerland, but there are a number of these around the world. So we use that as a measurement of the kind of total background counts, and we adjust for changes as those change. Then we've got our time series of corrected neutron counts. We can convert that to soil moisture through this calibration, as I mentioned, using the graph that I showed a couple of slides ago. And the calibration is undertaken on a particular day where you're measuring both the counts and then you make a measurement of the soil moisture manually. So we take soil moisture samples at a number of points from if you see this diagram in the top right, from the center of where the Cosmos station is, a number of intervals, 5 meters, 25 meters, 75 meters. Actually, we've been working on the specifics of the arrangement of these samples, but each a number of points around a radius at even points through the kind of field scale footprint. We take samples to make sure that we're getting a kind of average across the footprint by drilling into the soil, taking a fixed soil sample at different depths, and taking those back to the lab and calculating the volumetric water content, the dry bulk density, looking at the soil organic matter and the lattice and bound water. So basically baking those samples in the oven to different temperatures to remove the soil water that's contained within them, to get a detailed estimate of the soil, well, an understanding of the soil within those samples to give us an estimate across the entire footprint, and we use that as that calibration point. And we've been back to recheck calibrations, to redo calibrations to check that they fit on that calibration curve that I mentioned. So that's how we establish a relationship between cosmic ray neutron counts and soil moisture. And so we obviously need to measure some of those other things like atmospheric radiation. At the Cosmos site, there's a core kind of a very basic set of variables that you would need to measure if you wanted to calculate soil moisture. But we also, as this is like a research project, and there's a number of other things that we want to do with the data at these sites, we've built in a huge number of other components that we measure and take data from all of these things. So there's a full MET station with temperature, relative humidity, incoming and outgoing radiation. We have a 3D sonic anemometer to give us wind speed and wind direction at very high resolution. We have a weighing rain gauge to understand the actual rainfall input, so we can work out how rainfall is impacting on the soil moisture. You see the Cosmos probe here at the point in the site. And there are a couple of other bits that might be of interest. So we also install point soil moisture sensors at different depths within the site. We don't do those across the whole of the field scale because, as I'll explain in a minute, many of these are agricultural fields or fields that are used for other things, and it wouldn't be possible to have kind of instruments all over that 200-meter footprint. We also have a kind of soil heat flux plate, which helps understand evaporation, potential evaporation. And we also have these PhenoCams, which take pictures sort of 4 or 5 times a day in 2 different directions across the field, like this image here you can see. So there's a huge range of other instrumentation and monitoring that we undertake to help us with this monitoring. So currently we've got a network, and I think we're basically at the level where we expect to be of about 50 sites, 49 sites spread across the UK, and we've got that over the past kind of 5, 6, 7 year period since starting the project. There's a huge amount of effort put in to identify and organize the sites at which we set this monitoring equipment up. So we end up with, whilst we've tried to target the types of sites and the range of sites and the spatial locations of sites that we've got, it's also driven by the kind of access to sites where the equipment's secure and there's facilities and suitable phone access and these sorts of things. So we have a varying spatial density of the sites, largely because we're interested in the variability of soil moisture, and obviously in the UK, in the north and the west, the soils are very wet a lot of the time, and there's a lot more interesting applications and interesting variability in the soils in the south and the east. So there's a slightly denser network in the south and the east. We have sites that sample a wide range of climatic regimes across the UK, but also different land cover types, both from managed sites, agricultural sites, where the land cover changes over time, over years and throughout the year. Some of them are forest sites, many of them are natural sites, many of them are kind of nature reserves and those sorts of things that might be interested some of the JNCC delegates here. We also try and sample a range of soils and geology and topography. And where possible, we try and co-locate these measurements with existing research monitoring, both to kind of get the benefits of co-locations of instruments. And you might recognize some of the names here: Rothamsted Research and Northwick, and lots of these are sites that are used for other things. Hollin Hill is a British Geological Survey site. And many of the other ones you might recognise as being research sites. Some of them are agricultural sites where the farm managers are particularly interested in these research applications or particularly happy to have additional monitoring on their site. And we also have to meet a number of other site requirements. So the sites can't have kind of surface water, which would impact the soil moisture measurements too much, and a number of other specific requirements. So we're currently at the kind of level of network that we'd want to be, and we have been for a number of months now. So we've got data streaming in from all these sites. So here's an example of some of the data and little pictures of some of the sites from Scotland through the Midlands, southwest and east of England. And this is the soil moisture volumetric water content, so a percentage of the soils that are estimated as being saturated with water. And you can see the differences in variability and how we can use this data. So we end up with a daily principal output in terms of soil moisture as a daily volumetric water content record across the number of sites. And we're showing these here against a kind of maximum and minimum value for a given month, the monthly value, because we've only got a number of years of data to produce this kind of contextual bands at the moment. But as we move on, I'll explain in a moment, we're hoping to get a better understanding of the kind of broad range, the range of effectively the climatology of the soil moisture at our sites. Here's a bit more detailed example of a few different types of sites. So this is again showing volumetric water content. The top site here is a kind of a good, well-draining agricultural soil. This one at Wadston is perhaps a heavier soil that you can see drains slightly more slowly, with a slightly higher soil moisture content. And the one at the bottom here is an upland peat site at Plynlimon, so both much wetter but also peaty and therefore harder to measure. And I should say we've got the method has been developed for mineral soil, so we have very good confidence at sites with mineral soils, but sites with kind of high organic matter might a bit more difficult, with some sites very hard to kind of understand whether we're measuring the correct soil moisture. Maybe, for example, some of the forest sites where we need to do more research into exactly what the measurements are representing. And in particular, where the sites are very wet, as I mentioned before, the counts end up being very low, so you have a much greater uncertainty in the resulting method. So it's much harder to have a great deal of certainty about the results there. So it's, like I said, it's part of the program, as well as producing this soil moisture monitoring network, is actually developing an understanding of the applicability of these methods to UK conditions. So we're continually working on that aspect of the research to improve the method in different situations. So one of the issues I mentioned was about Cosmos against point sensors and how they might compare, or how the benefit of having this field scale measurement. So there's the issue of the general heterogeneity of the soils, and the fact that you're getting a better average across an area, particularly when you're thinking about comparing these in situ measurements with satellite data. If a point soil moisture measurement might be very unrepresentative of a large 1 kilometer, 5 kilometer pixel in an Earth observation data set. But there's also issues that I mentioned about the actual kind of installation and situation of some of these point sensors that makes an impact. So here's some of the data from our site in Rothamsted, where the black line here is the soil moisture from the Cosmos sensor. The red and green lines are from these point sensors that are inserted at 10 centimeter depth, and you can see that already that they're showing to be suggesting that the soils are drier than the Cosmos site, which you might question. If like I said, the Cosmos is supposed to be measuring over a slightly deeper depth than 10 centimeters, and also that these two 10 centimeter depth probes are giving quite different results, which might be a result of just different soils at those particular locations. But as we go through time, we can see that there's quite a change in one of the sensors. It increases above the Cosmos sensor, and then the red one does the same after a time, and then they go up and down a bit. But after a while, they established a kind of quite a consistent pattern, slightly probably more like you would expect in comparison to the Cosmos sensor, and more kind of aligned to each other. So there is these issues that we think about taking about kind of 18 months of kind of soil settling and bioturbation, when worms moving around, other things happening that might allow water to be running in against the sensor, and a bit of a seasonal cycle there. So, but we're kind of happy that after a while they tend to converge and be a bit more representative of the Cosmos kind of trends, at least. So just think about the rest of the data that comes from the sites and how we deal with that data as it comes in. So we have to do those corrections I mentioned with atmospheric pressure and things to produce the soil moisture data. And we've got that fully automated for all of our 50 sites. So we have the data streaming in, we automate taking it, uploading it to a database, applying automated kind of quality assurance, quality control, things like range and spike checks and various other checks that we do. We also kind of automate the production of plots and dashboard overviews to help with kind of visual inspection of the data. So we've got people who are constantly on looking at the quality of the data to ensure it's up to scratch. And we also automate all of these calculation of other derived products, as well as the soil moisture. We derive things like potential evaporation at the site from that range of MET measurements that we make. We've developed a new method of using this where there's snow cover on the ground to estimate snow water equivalents, which is quite interesting and quite a nice new application. And that's all, like I said, that's all fully automated. And I'll just talk through some of the data products that we get from the system. So we produce all these monitored variables. So these are the ones I showed you directly from the sensors: the precipitation, humidity, air temperature, pressure, the incoming and outgoing radiation, the wind direction, wind speed, or also this 3D wind speed data. We've got like a number of, we've now got, for the most recent sites, we've got this array of 12 of these point soil moisture sensors at different depths, which also give you a measure of soil temperature. So there's a huge range of available data that you can use for a number of applications, as well as use alongside the soil moisture, and hopefully they'd also be useful for understanding the Earth observation methods in terms of the actual, as Bernard was saying yesterday, the kind of dielectric properties and how it influences the radar backscatter and things like that. It must be useful information in some of these variables. These are some of the other derived products that we produce, as well as this kind of volumetric water content and soil moisture index. So converting that volumetric water content into a kind of into a equivalent scale across sites. We produce this, like I said, a time series of what the typical sensing depth of the neutron ray probe is. So we call this D86. So it's the volume within which I think 86% of the reading is taken. Sorry, I should have said on these previous ones. So most of the data that we measure is at 30 minutes. The precipitation we take from these weighing rain gauges at 1 minute resolution, which we aggregate up to 30 minutes. And then lots of these derived products are either at 30 minutes or hourly resolutions. So the soil moisture, we have hourly and daily resolutions, but we generally provide the daily data as a more settled signal. Similarly with the depth of the neutron, the depth over which the soil moisture measurement is taken. This is the corrected counts, as I mentioned. We have daily potential evaporation now. Net radiation means we adjust the pressure to sea level. We have a kind of 30-minute and daily albedo measure from the radiation measurements, which is used in turn to identify whether or not there is snow on the ground. And then from the soil moisture measures on days where we've identified that there's snow, we now calculate a snow water equivalent measurement. So again, all of those data are available, and we're working on new derived data all the time. I mentioned these PhenoCam images. So we get sort of 4 or 5 of these images per day from each site, one facing south and one facing north. And they you could use those to provide kind of qualitative information about the site, just on growing conditions, on, for example, whether there's snow or standing water on the ground. If we think where we think the soil moisture measurement is being affected, we can use these to check that data. But we're also in the process of automating it by putting a mask around the field areas within these images and calculating a kind of RGB time series from those. So we should have either a 4 or 5 times a day, or at least a daily signal of the kind of color of those fields, which could be used to understand the kind of senescence or the crop growth or other aspects. So there's potential other applications of that which might be useful. Got a range of ongoing work. So some of the sites have actually got flux towers at them. So we can produce actual evaporation data at those sites, and we're trying to integrate that within the Cosmos network. We're looking at kind of modeling at the sites with the MET data, and then trying to extend that back with other modeled MET series to produce a kind of climatology of the soil moisture sites, which might be useful to understand a bit more about the context of how dry it is on a given day. We can say the dryness in terms of volumetric water content, but if we know that's as dry as these soils are likely to have been on record, it's quite useful in terms of understanding the water resources implications. And we're also working on these quality control, automated systems for quality control, improving the kind of completeness of the series, including depth filling with AI. So there's a whole load of ongoing work with this. So we're getting longer series, and hopefully we're getting better series and newer information as we work on it. We deliver all this through our website. So Cosmos, I should know this off the top of my head, cosmos.ceh.ac.uk. Hopefully we'll be able to see that in a moment. And there's a range of information about the project, about the sensors that we make, about soil water measurements, and probably a better description of how these measurements are made. We've got a YouTube channel with some of these videos. There's a nice kind of animation of how the Cosmos measurements are made on there, as well as some of these PhenoCams turned into videos. And then for each of the sites within the website, you can go in and see details of the site, full description of the site, see maps of exactly where the station is and what the land cover is according to the land cover map, and and understand some other kind of metadata about the sites, like the soil classes produced from different data sets, the land cover across the footprint, for example. And then you can get time series plots. So either for each site, you can get the time series across all of the sites, all of the variables, or for a given variable, you can look at say the soil moisture time series across all of the sites in one go on a kind of dashboard to see what that says. So it's all fully visible, and that's all real time. So these graphs are updated every kind of hour or so. And as well on the website, we have this kind of live map of the current soil moisture according on the current day, either as a soil moisture index or as the volumetric water content, just to kind of show the current status in a live situation. All the data is downloadable, freely downloadable and usable. We deliver all of our data through the NERC Research Data Center called the Environmental Information Data Center, which you can go to this page and find data sets. So there's a record like this. It's currently up to 2017 rather than 2015 in terms of the data that we make publicly available. The data's got a DOI, so it's a fixed kind of research resource that you can guarantee is not going to change. Although we do update it every year, and when we do update it, it will include changes to the method, for example, where we've improved things. So like I say, we're in the process of updating this now to 2018. And within this dataset download at this DOI link, you can get supporting information, documentation that describe the dataset and some of the ways it was produced, as I've been describing today. So we really encourage people to make use of the data. We want to see impacts from it. And if you can either download the data here, but if you want to get in touch with us and ask about the data, and you're encouraged to do so. We also produce these kind of data products, summarizing all of the data. So these are the monthly maps of the data produced at the beginning of every month, and you can sign up to receive these on the website. That's the web address there on the homepage, and these contain both maps of the data and graphs of the data. There's a detailed user guide on all of this instrumentation and how things are measured, much more detail than I can give now. And yeah, as part of that monthly summary, there are all of the kind of graphs of the recent data. So is another use of the data. Currently, it's being used within our UK water resources portal, where we've included it in tools alongside river flow, groundwater level information, rainfall data. So in real time, pulling together data from the Environment Agency, from the Met Office and others, looking at data for a river flow catchment and the river flow at site, as well as soil moisture at that site. So this is like I said about climatology, allows us to describe the river flows in relation to the kind of longer term context. We can't quite do that at the moment for the Cosmos data. We can just show the absolute values, but what we're aiming to do is to be able to show how that relates to the long-term context of that particular site. Cosmos is being used outside the UK, and we're not involved in all these projects, but there's a big Cosmos network in the US, which is where it was initially developed and established. So there's longer records across quite a large scale network, probably less dense, more stations, but although less dense than the UK, given the scale of the United States. There's a Cosmos in Australia network, which is running. It's used in this Torino research infrastructure, hydrological research infrastructure in Germany, and we've been involved recently in helping establish a Cosmos India network of kind of 7 or 8 sites across India, producing Cosmos data, soil moisture data, for a range of applications. I want to acknowledge it's a huge range of people, not just working on the project, but the site hosts are really critical for us to help understand, access the sites and develop these infrastructures. And there's a huge number of, can't mention all the different organizations, but yeah, research partners, agricultural partners, industrial partners involved in that, as well as huge acknowledgements to the rest of the group at CEH. Again, like I said, a big team working on all aspects of this, from the field deployment to the organization to the web development. And I was going to talk about a few related projects that might be of interest, where Cosmos has been used either alongside modeling or alongside Earth observation data, or sometimes kind of amalgamating all 3 of those things. So I think there's a continuing developing area where people are trying to find a kind of sweet spot of use of these data for the different applications, between these observations like Cosmos, where you've got quite high temporal coverage, but really, even though we've got a large, quite a dense network across the UK, it's fairly low spatial resolution, but hopefully accurate. Although I've got a question mark there because we're still developing aspects of the different soil types sometimes and areas of that. So trying to find a sweet spot between those observations like that, the models which are, can be have full coverage both temporally and spatially, but are models, so they've got their own kind of implicit estimations in there. And then Earth observation, where you've got high spatial resolution. What's particularly important, having the real-time data is really key. So none of this work is mine, I should say. I'm just trying to point out some resources both from CEH partners and other people. In particular, I point you to this. There was a session at the recent EGU conference doing a lot of comparisons of some of these data sets, and lots of interesting work there. And it's all kind of stuff that's online. Some of the people have put the posters online as well. And in relation to the model data, I was going to point you towards another data from CEH, where we've produced a 1 kilometer data set of meteorological driving data suitable for driving a particular land surface model that we run called Jules, but obviously suitable for other models as well. So that's 1 kilometer, rainfall, temperature, radiation, those sorts of variables, often downscaled from other sources. So it's not claiming to be the exact at that scale, but it's the best estimate at the 1 kilometer scale. And again, this is a freely available data set that's downloadable from this data center. So this provides daily data from 1961 to 2017 at the moment, and we're regularly updating that. It's been run with the model, with the Jules model, to 2015 already over that time period, which includes the soil moisture data set. So there's a daily soil moisture data available for that period, which is quite useful in relation to these modeling. Some of the questions yesterday were talking about extending periods backwards, and there's a potential opportunity to do that with model data. So we've got a project called HydroJoules where there's a lot of this work going on, trying to focus on this 1 kilometer UK scale and work out how to make best use of both the Cosmos data and the soil moisture data. And like I said, this isn't work of mine, this is work from colleagues at CEH and others. So one recent project in HydroJoules has been from Jian Peng, and he sent me a slide to show that it was presented at this recent EGU meeting. And he's done a comparison between SMOS map and some of the Sentinel, Sentinel product with this Jules chest soil moisture, and comparing that to the Cosmos UK site. So he's got comparisons of that data, and then he's also done a kind of triple co-location method, so not using the Cosmos data to kind of blend those data sets together and produce a kind of merged data set, which you can see in the bottom right here. So it's a kind of merging of modeled and Earth observation data, and then he's redone that comparison with the Cosmos data. So you could read some of that work here. Again, that's with colleagues at Reading University, National Centre for Earth Observation, and CEH. I mentioned some of the issues with the modelling, that you've got intrinsic assumptions about aspects of the model. One of them, potentially the most uncertain of which, is the soil parameters that are used to do that soil moisture modelling. So there's been work with the Cosmos data and the Jules data to try with a data assimilation approach to use those meteorological observations at the Cosmos sites to drive this Jules model to get time series of modeled soil moisture at the sites, compare that to the actual observations, and then adjust those soil parameters, those soil physics parameters in the model to get a better modeled output. And then they're looking now to where is that possible to scale that out to get a better modeled estimates across a wider spatial scale, say across the UK. So again, that's with partners from Reading, working on the data assimilation framework, as well as people at CEH. And again, I think this is going to be published in HES, it's been submitted anyway. And there are a couple of other applications I picked out from this of Cosmos data from this EGU session. So one is John Beale, who was, I think he was on the call yesterday. He's looked at another type of model, soil moisture model, applying that at the Cosmos sites and then comparing it to Earth observation data. And there was another poster looking at evaluating some of the sites, Cosmos UK sites in the southeast against some of the surface soil moisture products. So I think I'm coming up to the end of my time. So just to summarize, I mentioned at the beginning this Copernicus in situ project, which is looking across the Copernicus services, trying to help coordinate soil moisture data, and where we're focused on hydrological data. In relation to soil moisture, the main conclusion is that it's basically a fundamental lack of the measurements in the first place, which is a kind of interesting thing to try to address. I guess it will help if we can demonstrate the benefits of using these types of national scale networks such as Cosmos UK. If they can improve the use of Earth observation products, would be an incentive for monitoring at that scale in other countries. And then the rest of the talk, I spoke about the Cosmos UK network. So just to summarize, that it's quite a dense network, I'd say, possibly the densest in the world at the national scale, providing near real-time field scale soil moisture measurements over a range of about 200 meters in depth, from between 10 to 70 centimeters in depth, depending on the conditions. With the Cosmos data, there's this range of other products providing a full set of met variables, but also things like PE, snow data, these PhenoCams. There's a huge amount of work underway to bring the combined benefits of these observations with modeling and Earth observation. The Cosmos data is all freely downloadable. And if you've got interest in kind of collaborating at a particular site or of access to the data, please do get in touch at that email address. So that's the email address for the Cosmos team. If you want to ask me specifically a question, you're more than welcome to email me. I know we've got plenty of time now for specific questions as well. So thanks very much.
Thank you, Matt. That was very interesting. If you leave your slides up, just in case there are any specific questions about them, that'd be great. So now I'm going to hand over to my colleague, Dr. Gwar Jones, who will be facilitating the questions session. Thanks, Gwar.
Yes, hi Matt. First of all, thank you for a very interesting talk. I learned loads about the work that you're doing with soil moisture that I wasn't aware about before, so that was really good. We do have some questions and only 10 minutes to get through them. So the first question is, there is a large void in coverage over Scotland. Are there any particular reasons for this?
Like I said, I think we were aiming to make sure we had good coverage across the country as a whole. But in terms of the particular interest in variability of soil moisture, we were focused on, like you'd have noticed that there's a higher density in the south and east of England where there's that greater variability compared to the kind of potentially wetter north and west. I'm just going back to that slide there. Can you still see my
Yes.
slides on the screen, just to put that map up? So I don't, well, I don't think it's particularly considered a void, but maybe, yeah, it could be that there'd be greater benefit in more in Scotland. We have got quite a high number of sites in across south and eastern Scotland, as well as to the west and the south. But yeah, you're right, in the far north and west, there's a lack of sites. But like I said, we know that there's at the moment anyway, it's harder for us to make use of it in particularly PT sites. So there may be an element of that there, as well as practicalities of access to research sites where we can co-locate the equipment. But there could be a whole range of issues there, but it's certainly not a deliberate, and we don't want to underrepresent any particular areas.
Great. So next question is, who do you see as the main current and potential user groups for these products?
Well, we've already got lots of collaborations in research, because I suppose that's the initial focus, and of getting this data out through research, but we know that there'll be, or there already are, direct applications in a number of areas. There's a group that does hydrological modelling for Flood Forecasting Centre that's based at CEH, so they're looking at this data and how it could be used in flood forecasting models, and that should make its way through to national scale flood forecasting. We're engaged directly with some of the agricultural groups where we based our sites. They're interested in use of it for agricultural data, agricultural understanding. So there's a big range of things already. There are people, like I said, there are people interested in greenhouse gas emissions from agricultural fields and how soil moisture affects those sorts of things. So we don't have we're not targeted on a particular area. I think it's inevitable that research is the kind of first place to start things up, but that research is across quite a range of application areas. So we're trying to set the network up and the data access and everything else in order to facilitate a broad range of uses, I think. So,
yeah, and it's good to hear. It's good to hear that you're collaborating with people looking at using this data for flooding, because that was a question that came up yesterday with the Earth observation projects. So next question, does Cosmos just provide data on each specific measurement site, or do you also have any products that extrapolate from these sites or model from them, e.g. by land use type, to give a national scale soil moisture map or similar?
We don't at the moment, but that is something that is of great interest, well, to us and others. And some of that work I mentioned at the end is a start of attempts to try to see what could be done there. Whether it's the best approach is like you say, trying to use the information at a site and understanding the. Sorry, can you hear a lot of noise in the background, or is that okay?
No, carry on.
Okay. Drilling outside my window. Either extrapolating from a site, knowing the soil type and the land cover, etc., might be quite difficult given the range of soil types and land cover types we're not going to have a huge number of measurements across any single one of those combinations, and obviously the geographical locations makes quite a lot of difference. So I suspect there'll be more potential in using something like the modelled data sets, which could help. You can imagine being able to use as a way to extrapolate that, and the work I mentioned on adjusting those dual soil parameters is potentially a way to do that. So rather than extrapolating the Cosmos measurements, you're using the Cosmos measurements to effectively improve the model results, and then those model results can be applied at a national scale. But I think that's where the Earth observation comes in, is that's got much better. Well, it's both got that very real-time access to the data, but it's also got inbuilt, it's a direct understanding of what's happening on the ground, rather than the assumptions that the modelling is taken, where any place with similar soils and similar land cover might give you the same, and rainfall would give you the same result. So yeah, I think it's like I said, there's a sweet spot between combining all of those things. Yes. I think.
And Earth observation data gives you a measurement for all of the area covered, so you can model on each measurement, so you have a measurement per area, as opposed to extrapolating a model where you're putting in different inputs to get an output. So yeah, it's definitely a balance, isn't it, as to what you want, how to use the data. Great.
It's an evolving situation. Even Bernard yesterday was describing how even the Earth observation products methods are developing as well, to start to include more dynamic land cover and things. So I think between us all, there'll be it's constantly evolving.
So the next question is related to peatland again. So you have mentioned that it is more difficult to set up one of these sites due to the measurement difficulties in peatlands, and you did mention that Plynlimon was a peatland site, but do you have any other sites in your network located in peatland, and could the technique be useful for monitoring peatland condition if you use the data slightly differently?
Well, we hope it will be, and there are a number of peatland sites. So there's one down in Tadham Moor here, there's some in Scotland, a more peaty Glensoch. up in the north. So it's one of the areas of focus that we're trying to work on to see how those methods could be improved to give a better understanding of proper soil moisture measurement at those sites. But so yeah, something we're working on. I think they hope that they'll be able to work on that. But this at the moment, it's a similar. It's not related to Plinlimmon. It's a similar problem across our peat sites that is much more difficult to model with this method there.
Great. So next question, you had a slide at the beginning, I think, explaining a little bit about some of the applications where the Cosmos UK data is used for. Do you have more details on use of Cosmos UK data for wildfire mitigation?
Those were general areas that we know that there is use for, rather than particular things where we've got a definite, a particular project. So if there are people interested in looking at in that particular area, I don't have a vision of the full number of users where we've had specific. People who just download the data, we don't necessarily hear exactly what they're doing with it, but we do have a lot of people come to ask us about the data as well as use it, in which case we have a reasonable idea of what people are doing. I don't have a sight across the whole range of those things, but if people are interested in using it for that purpose, they're welcome to get in touch and to find out
Great.
more.
Maybe something we can discuss later in the collaboration session. So next question, do you know of actual examples using the Cosmos network for irrigation scheduling, and what is the planned spatial resolution of the network? Two questions in one there.
Yeah, that's fine. So the last one is, I suppose this map kind of says it really. That's kind of pretty much where we are at the moment with the funding we've got and the funding we've had for equipment. So that's the spatial resolution we're expecting for the time being. And there are numbers of people, again, but it's at the research level looking at these sites. So there's particularly in East Anglia, Redmere is a kind of research farming or a farming company with a great interest in research, as well as some of those other agricultural sites. There has been work on developing with other universities, University of Lincoln, a Cosmos rover, so mounting multiple Cosmos sensors on a kind of automated robot that goes around the field to find kind of variability in a field scale, actually across the field in terms of the variability. So and that's been used in East Anglia. So there is research into use of it at that scale as well. Yeah, but I don't know. I don't think, as far as I'm aware, there's nothing in place where, for example, it's used as an automated way to start or stop irrigation at the moment. I think it's still at the research level.
Okay, good to know. So next question, can you explain more about the difficulties of Cosmos measurements at forest sites, and how does Cosmos cope with above ground water in vegetation?
Yeah, that's a good question. Yeah, okay. I think there's a number of aspects of that. So the Cosmos sensors at those sites have to be mounted at the canopy level. So they're usually they're research sites where the infrastructure is mounted at a level to make use of that. The other issues that come with that I think it's in particular, one of the sites that we have difficulty kind of interpreting is one of our forest sites, but we've got a number, so Gisborne and Harwood Forest. So I think the particular issues vary from site to site in terms of the forest sites. There's just that aspect of canopy soil moisture just adds another complication into it, into the factors, and makes it harder to interpret the data there. There are specific methods, and there is existing research and taking account of whether it's canopy level soil moisture or soil moisture even in the field around a site. If you're an agricultural field and it's a crop that's taking on a particularly large amount of water during the growing season, it will affect the soil moisture measurements there. So there are ways of taking account of that if you can estimate what the moisture content is from other measurements, for example. So again, I don't want to sound like a broken record. It's definitely an area that is actively being researched with the idea of being able to use that to get a better understanding of.
And something that this data and the Earth observation data has in common as well, which is quite rare with in situ and Earth observation measurement, that vegetation and water and canopy is actually impeding the measurement of soil moisture in this case. So we've got a handful of more questions. Sorry. Carry on.
We've already got lots to get through. I was going to say, I think that there's definitely potential to use it in those forest sites. It's not that it doesn't work at those sites. It's just there's extra complications in understanding, making use of the data. Yeah.
So we've got 4 more questions, and hopefully some of them will be quick. So this next one is again related to peatland, but I think lack of sites this time. So there are no sites in the Peak District area where much work is done on peatland restoration by the moors for the future partnership. I am sure the Cosmos data would be of great benefit for their work, e.g. monitoring resilience of this delicate peatland. Is there any plans to install a Cosmos site in this location?
Like I said, I think we're at the number of sites that we kind of expect. It's not to say that there won't be opportunities for more sites, in which case that might be of interest. We definitely have some sites where they're either active. Down in Tadham Moor in the southwest is kind of actively, a peatland site that's actively managed, and there are other sites where there's definitely interest in use of the data in relation to peatlands. So Moorhouse, for example, is a research site up in the Pennine. So I don't think it's the lack of a site there doesn't mean that that's not an issue that could be looked at with the data that's produced from the network. It's just that it's not specifically focused at an individual site. And I think that's the case for most of the network in general. You can't really look at these as being targeted to address an issue at a particular site. We're trying to put them on a range of different soil types and landscape types, etc., in order to understand how soil moisture is varying at those sites, and hopefully that would be applicable to other sites of a similar type, if that makes sense. Sorry, I hope that's not too much of a cop-out. But I'd say that in general, that we're not most of these sites, we're not trying to address a particular issue at that site. It's trying to get a broader understanding of soil moisture variability in different conditions.
Yeah, but there's opportunities in the future, I guess, like you say, so that's good to know. So the next few questions are related more to Earth observation now. So the next question, as the sensitivity of Earth observation soil moisture is often more in scale of 5 centimetre depth in terms of measurement, is it not an issue to compare with the Cosmos network whose measurements start at 15 centimetre depth?
Yeah, and I think that's going to be a key part of doing those comparisons. I don't think it excludes the use together in any sense, but as Bernard was explaining yesterday, whilst the measurement is generally in particular at that depth, they estimate data at deeper depths. So it's either choosing one of those products that is more representative of the depth, or trying to use the Cosmos data to understand, what's happening at the surface. Cosmos data particularly, and the rainfall data, understand what's happening at the surface to see how you could work between those two different products. And I think that's the case. You've definitely got different measurement techniques in all of these things, modelling and the Earth observation. It's trying to work out ways to bring those together to make them as comparable as possible, rather than just saying, these are measurements of the same thing, say the soil water index, and comparing them directly like that.
Yeah, and I guess the next question is related to that. So is all the Cosmos data used by Copernicus, SSM and SWI? And if so, what is the impact on quality of these products? Presumably greater confidence the nearer to a Cosmos site? ?
So at the moment, this data set isn't in that International Soil Moisture Network. So that's one of the things that, obviously it's an obvious thing to work on, and we're going to talk to that group at Vienna about that, because they manage that database. At the moment, none of, as Bernard kind of suggested yesterday, none of those in situ measurements are used. They're used as validation of the products. They're not used to actually adjust the products. So that would be really interesting to see if there was a mechanism not just to use it as a way to say, you know, how well is that product doing in this particular area, but are there ways to actually adjust the products? You know, if this data is available in real time, can you actually integrate it in real time in a more sort of data assimilation approach? And I think that would be very interesting. But obviously, in order to do that at the larger scales that they're looking at, you'd need this density of network across across Europe, at least. So I was interested to see that images he showed of, well, there was Poland where it was not working particularly well in some conditions, and in Italy where it was working particularly well. And I was kind of interested to imagine how, what you could do to adjust those data sets if you had this sort of data. So maybe there's a good UK application for those things. But I hope having this data from this network should mean that, you know, our understanding of how usable that Earth observation data should be, you know, really good across the UK scale once people have started to integrate it with these measurements, hopefully.
Yeah, I hope so. So we should see more of that sort of stuff coming. Maybe we can be discussing that as well in the collaboration session this afternoon. So you mentioned that Cosmos also uses the information from the PhenoCam. Can you explain more about what and how the information is incorporated?
So at the moment, in terms of the actual automated process, we just pull down those images and have them all available. And like I said, we use those to assist with our validation of the data, that if there's issues that look some funny data at a site, we can see whether there's standing water at a site or snow cover or these sorts of things, or understand the change in the land cover if farmers ploughed a field or taken a crop out, for example, that might affect the data. So in terms of the actual real-time use, there's nothing at the moment, but they've both developed the code to produce an RGB signal across the mask. So we mask out just the part of the field that is you know, showing the kind of crops or the land cover, and it's basically like a satellite color product, like a standard sort of visual wavelength kind of product would be looking at that field, the color of the field basically, and using that as a way to understand changes in the greenness in particularly of the field throughout the season, just to understand whether you could automatically pick out changes in the crops, or whether it's a way to understand development of those crops or crop quality or something like that would be of interest. But at the moment we're just kind of producing that as a data product that people could make use of.
Great.
I say wouldn't,
so
it's coming. That aspect of it will be coming as part of the live system.
Good to know. So I'm now been told by Lynn that we have no more time for any more questions, but we got through most of them. So Lynn, back to you.
Thanks.
Thank you very much, Gwar, and thanks again, Matt. Very interesting set of questions. So now we're going to take a short break and we'll be back in 15 minutes to hear about all the practical applications of the SWI or SSM products.